Hi everyone, welcome to the number properties session on factors and multiples. Factors and multiples, you may expect some simple problem solving questions or you may expect some data sufficiency questions also around this. So let's start the class. So first let me tell you what is a factor or a divisor. Factor is a positive integer that divides evenly into an integer, or when divided the remainder is 0. 1 and number itself are always a factor of a number. So for example, if 8 is divided by 4, the quotient is 2 and the remainder is 0. So 4 is a factor of 8. Similarly, 1, 2, 4 and 8 are all factors of 8. 1 and number itself are always the factors of a number. What is a multiple? A number is said to be a multiple of any of its factor. So for example, in the above example, 8 is the multiple of 1, 2, 4 and 8. So now let me introduce to you factor pairs. Factor pairs of any integers are the pairs of factors that when multiplied together yield that integer. If a problem solving question comes that how many factors are there of a particular number. If a number is small, let's say less than 100, you may use factor pairs for a quick solution. So let me take an example of a number 90. So for a number 90, I need to find how many factors are there. So I'll use the factor pairs technique. So in the factor pair techniques, first I'll build a columns. So one column I'll name it as small and one I'll name it as large. So the first thing, I'll start with the smallest integer, that is 1. So if I have to see 90 divided by 1 is how much? It is 90. Then I'll take the next number of 1, and if it is divisible by 90, so I'll take 2. 90 divided by 2 is nothing but 45. Then I'll take the next number 3. 90 divided by 3 is nothing but 30. Then I'll take 4. But 90 is not divisible by 4. So I go to the next number, which is 5. 90 divided by 5 is 18. Then I similarly go to the next number 6. 90 divided by 6 is nothing but 15. Then 7. No, 90 is not divisible by 7. 8. No. Then 9. 90 divided by 9 is what? 10. So here there is no need to take 10 here because the 10 has already come here. So the factors of 90 are what? 1, 2, 3, 5, 6, 9, 90, 45, 30, 18, 15 and 10. So there are in total 12 factors of 90. So this is called the factor pairs method. So to summarize, make a table with two columns labeled small and large. Start with 1 in small column and number itself in large column. Test next possible factor of 90, which is 2. So write 2 underneath 1. Divide 90 by 2 to find factor pair 45 and proceed so on. So the number of factors of 90 are 12. So now let's see some of the divisibility rules, which are very important for GMAT. So a number is said to be divisible by 2 if its one digit is a even number or a 0. Then the number is divisible by 2. So for example, 32 is divisible by 2, 46 is divisible by 2, 96 is divisible by 2, 100 is divisible by 2. You see the ones number are either even or 0. Whereas any of the odd numbers are not divisible by 2. For example, 7, 9, 91, 73. These are not divisible by 2. So now let's see the divisibility rule of 3. A number is divisible by 3 if the sum of digits is divisible by 3. Let's take a large number, 9, 1, 6, 5, 4, random number. So what is 9 plus 1 plus 6 plus 5 plus 4? It is equals to 10, 16, 21, 25. So since 25 is not divisible by 3, so 91654 is not divisible by 3. Now let's take example of 91656. The sum of digits is 9 plus 1 plus 6 plus 5 plus 6, which is equals to 10, 16, 21, 27. So since 27 is divisible by 3, so 91656 is divisible by 3. Now let's see the divisibility rule of 4. A number is divisible by 4 if the number formed by its digits in the tens and ones place is divisible by 4. So now let's try to write the number 8, 2, 3, 4, 1, 6, any big number. So the tens digit is 1 and the ones digit is 6. Since 16 is divisible by 4, so this complete number is divisible by 4. So let's take another example, 93721. Since 21 is not divisible by 4, so this number is not divisible by 4. So now let's see 5. 5 is very simple. A number is divisible by 5 if its ones digit is 0 or 5. So for example, if the number is 9555, definitely it is divisible by 5. Or if the number is, let's say this, the last digit is 0, so both these numbers are divisible by 5. Now let's see the 6. A number is divisible by 6 if it is divisible each by 2 and 3. So for example, 91656, it was divisible by 3. Since its one digit is also an even number, so it is divisible by 2. So this number 91656 hence is divisible by 6. So 7th rule is a bit complex. So GMAT generally don't test it. So I'll go to the rule of 8 directly. So a number is divisible by 8 if the number formed by hundreds, tens and ones place is divisible by 8. So for example, let me take another example of, let's say, 92310 Here if we see the number 108, which is nothing but hundreds, tens and 108 is not divisible by 8. Hence, this number is not divisible by 8. So now let's take another example. 123032. If we say that 032, since it is divisible by 8, hence this complete number is divisible by 8. So now let's see the rule of 9. A number is divisible by 9 if the sum of digits is divisible by 9. Let's take any random number. Let's see the sum of digits, 6 plus 3 plus 4 plus 1 plus 5, which is equals to 9, 13, 14, 19. So since 19 is not divisible by 9, so this complete number is not divisible by 9. So in the following slides, I am showing some more examples for you to go through. So these are the simple divisibility rules. Now there are some more rules to factors and multiples which are very important from data sufficiency point of view. So first rule is addition and subtraction of multiples. For example, if you add or subtract two multiples of number n, you get another multiple of number n. So for example, 36 and 48 are multiples of 6. So 48 minus 36, that is 12, is also multiple of 6. 48 plus 36 is equals to 84 is also multiple of 6. So this is a addition and subtraction rule of multiples. Another rule is a factor foundation rule. If A is a factor of B and B is a factor of C, then A is definitely a factor of C. So let's take the example of number 84. 84 is nothing but 14 into 6. 14 6 are 84. And what is 14? 2 into 7 is 14. And what is 6? 2 into 3 is 6. So what this factor foundation rule says is 14 is a factor of 84. 7 is a factor of 14. Hence, 7 is automatically a factor of 84. So what this rule says, if we take example of 84, 7 is also a factor of 84 if 7 is a factor of 14. Let us take some examples of the data sufficiency questions to understand it. Is x divisible by 11? Since it's a data sufficiency question, so we write simply AD, BCE. So let's take the first statement. X is equals to A plus B, where A and B are whole numbers. We don't know the values of A and B, and we don't know whether these are divisible by 11 or not. So the first statement itself is not sufficient. So we strike out A and D. Now let's take the statement 2 alone. A is divisible by 11, B is divisible by 11. So we tend to say that okay, x will be divisible by 11. However, this is a trap. In the statement 2 alone, there is no relation mentioned between A, B and x. So statement 2 alone is also not sufficient. Now let's take the two statements together. X is equals to A and B, where A and B are divisible by 11. So definitely by addition rule of multiples, X will be divisible by 11. So the answer option is C. So now let's see the second question. Is 7A plus 5B divisible by 12? Okay. Is 7A plus 5B divisible by 12, or is 7A plus 5B multiple of 12? So we write AD, BC, E. Okay. So the first statement says A is multiple of 12. If A is multiple of 12, then 7A definitely will be multiple of 12. Okay, but it does not talk about B at all. So the first statement alone is not sufficient. So I strike off A and D. Now let's see the second statement alone. B is multiple of 12. If B is multiple of 12, then definitely 5B is also multiple of 12. But similarly, it does not speaks about A. So I strike off B. Now let's take two statements together. If 7A is a multiple of 12, 5B is a multiple of 12 by both the statements together, then definitely 7A plus 5B will be multiple of 12. So the answer option is C for this question. So factors and multiples chapter. So mostly the concepts are tested in data sufficiency questions. If you will get a problem solving question, it will be very simple question like how many factors are there of a particular number, and generally it will be a smaller number. For larger numbers, we'll see it in the video when we discuss about prime numbers. Okay, thank you so much. See you in the next video. Bye bye.